Thank you all of you for coming to this talk. Just a brief presentation about Daedalus, our company, or my company. We're in the business of making text analytics, text mining products for extracting semantics from unstructured data. Well, the talk is about social TV, so casual talk for late Friday, or Friday late. I have to apologize for my English. It's not as good as I would like. So if someone really gets annoyed, please take a relaxing cup of coffee and enjoy the rest of the day. For the talk, first I'm going to introduce what it's social TV. And well, I'm not going to present a solution because we're still working on that. But I'm going to present the first exploration, the first iteration of a system that we had built to monitor conversations on social streams, on Twitter particularly, and trying to provide online visualizations for different use cases. For that, the main building blocks are trying to understand what the people are saying on Twitter first, and then once we have extracted the valuable information from text and other fields, we need to store it in a place and be able to query it online. For that, we use a database that probably most of you haven't heard of, which is SenseiDB. And finally, I will talk some of the lessons we learned in the process, and we try to implement a second version. So first of all, which of you have a Twitter account? Well, most of the people. Which of you have watched television and have connected to Twitter to see what the people were talking about? And which of you have already commented in the hashtag that television programs are using? Well, a much reduced number, but some of you are already part of what is social TV. If you go a couple of slides back, even if we didn't get the Olympic Games, after that day, the most commented thing was not that we lost, was that Ana Botella had very bad English. And this is in fact social television. The people is already going to Twitter for commenting and following the news and the TV programs that they are accustomed. And this is not something that just is happening for a single event, but every night at prime time, the people, as they tune in their TV, they're also opening Twitter or whatever other social network. But Twitter is easy because you have public data, and they're turning into the hashtag of the program, seeing if the others are commenting or what are the other people saying. And well, this is also related to other trends in television, like second screen, the way that you use a smartphone or tablets at the same time that you're using television, probably in unrelated ways, just to talk with your friends and WhatsApp them. But the people is also talking, it's also trying to get more information about the program they are watching, or some of the actors, or some of the people that it's commented on television. And this is also something that the TV broadcaster and the TV producers are already taking into account, and they right now start talking about transmedia, which is let's say, a new way of telling stories, where you try to tell the stories, tell the story in different media. And of course, they're very interested in understanding what the people is saying in social media and integrating them on their programs. Probably you have already seen some examples in television where they plot visualizations of what the people are saying, or they plot tweets, or they can even change the program or parts of the program as they see feedback from social networks. So this is also not just even for TV, but we have a lot of social data for sports, also during elections and when something bad happens, like disasters, earthquakes, or whatever. And it could be interesting to analyze what the people are saying in this situation and do it online, or, well, it will lax on Laxus in real time. What these have to do with big data? Well, the volume is not that big yet. If for popular programs, we have like for typical programs, we have like 1,000 of comments every night. But if you go to social formats like The Voice, La Voz, this goes up 2 orders of magnitude. We have like 500,000 comments every night. The show is broadcasted. So volume is not just that problem, but definitely if you want to provide online insights, and we will see who could be interested later, velocity and variety are definitely a problem. Velocity is a problem because you have to handle new messages with low latency in order to keep the viewer updated. And you have to manage burst in the volume of tweets. And variety is important because, well, social network data is complicated. Even if you just cut up and you stick with Twitter, Twitter data have complex data like location, like timestamps, but like also multimedia. But text is particularly important if we want to understand what the people are saying. And moreover, this text could be written in several languages, depending on the applications. Yeah. Yes. But who could be interested in this kind of application? First of all this game started because the viewers started to comment on social networks about the TV programs. So now that the things start to have to get volume, the broadcasters, TV channels, are interested in understanding what the people is commenting about their own programs to be able to react. And of course, brands that are those who are paying for television in the end want to know where they have to advertise. So for viewers, there is several motivations in order to use a second screen and while they're watching TV. And, well, it could be just check if the rest of the people think the same as me. I give you here a couple of examples that we already built of visualizations that could be interesting for viewers, or unless that we started working with that. The one I don't know if you can see it well. The one at the top, it's for a football match, and it represents the volume for the two teams, the Real Madrid and Barca. It could be something that you would like to see while you're watching TV, maybe extracting the most relevant comments, maybe even being able to focus on what are people commenting on a particular player. And, well, you would like to do this on real time, that the visualization animates online as the time goes. At the bottom, you have a mock-up for an application that we are building. It's already built, but I cannot show you the final slide because it will reveal too much about our client. The idea is once you have a lot of comments in a TV program, you don't have to go beyond the thousands. well, it doesn't make sense. You're not going to Reddit anyway. But you could do still interesting things that the user could use to keep updated of the conversation. And one of the concepts that we are trying to do in this case, the example was for kitchen nightmares, pesadilla en la cocina. It's trying to understand what are the people talking about. It's like a kind of trending topics for the program. And for that, we use semantic technology to extract the main topics and categorize them. And it's what you have at the right. And once you click in one of these entities that are relevant for the program, you can go and focus on particular comments that are that the people are saying, in this case, about El Pozo Viejo, which should be a restaurant or something like that. Well, that could be also enriched with sentiment. For example, if the people are thinking, well, Chicote is doing well or Chicote is doing bad. Chicote is the chef in this program. It could be, well, we're just checking interesting visualizations for users. The same kind of functionality could be offered for channels, for broadcasters, if they want to understand more in detail what the users are trying to say. So this is again with Chicote, the Spanish chef. For this case, the visualization is for Top Chef, the program that started like a couple of weeks ago. And we made a test for a visualization that, well, apart from the photo, the 3 different chefs, you have data collected on real time from them. You can see, oops. You can see the volume of the conversation and the ratio that changes. And you can see a green bar and a red bar. That's the sentiment that the people is expressing about any of the chefs. For that could be like a starting point to monitor, okay, what are the people thinking about the guys, about the content I am providing? And from that, you can drill down and go to the detail of the contents. Okay, what are the people thinking about Chicote? Is it good? Is it bad? Why? And answer these kind of questions. But for all this, what we have is a basic analytic tool in the backend. Finally, for brands, we could be doing similar things. This is not our focus right now, but of course, brands could be interested in things like checking if the reputation of the program is the one that they want. I don't have problems with the content that it's appearing, or maybe just selecting what is the program where I have to put my advertisement to reach the public I'm interested in. This is an external example from Bluefin Labs, a company that Twitter acquired during last year. So enough for the introduction. I hope you and I managed to convince you that social TV it's growing and has a lot of applications for you as viewers and for broadcasters, for example. Let's see the architecture, that it's pretty basic. It all starts with tracking the Twitter stream online. For that, we need to obtain keywords and the time of the programs and all this metadata to organize the monitoring. And we extract that from the APG guide. And well, once we have the Twitter stream focused on the programs that we are monitoring, the next step is trying to add metadata and understand what the people are saying in their comments about the program. And for that, we use our own tools, textalytics, which are able to extract important meaning and snippets from the text. And finally, once we have an ordered data structure with all the Twitter data and the data we have used to we enrich, the problem is indexing it in a sort of semi-structured database called SenseiDB, which provide basic analytics, and on top of that, we build the visualizations. So actually, the most interesting parts are the textalytics functions that I'm going to present, and I will talk a little bit about SenseiDB and how it compares with other similar things like Solar or Elasticsearch. So for understanding the bugs, we use our own tool, Textalytics. This is a set of the different functionalities that we have available. Of course, we don't use all of them in this kind of application, but I will present some of the ones that have some we're using in building these visualizations. So one of them is language unification. Twitter is already providing it from a couple of months ago, but it's important because even if usually hashtags are very localized, and with that you catch mostly tweets in one language, usually there are a lot of ambiguities in data, and also for international events, if you start catching tweets about the Oscar with the usual hashtags or keywords, it will enter any kind of language, so you want to filter it. And this is the basic step to avoid uninteresting data. Yeah, for the rest, I will give you a brief overview of what are we able to extract with this screenshot of the demo. You can try it online at textalytics.com. One of the things we are able to extract is categories, thematic categories. Like, for example, in this text that is longer, it's a news piece because it has more data and it has better visualization. We're providing categorization, like this news is talking about WikiLeaks, and it talks about politics, about network security, about crime, and this is one of the data that we're able to extract. Then we're able to extract name entities, that is the important people that it's mentioned in the news, in this piece of news, and like Obama or WikiLeaks, and we're also able to provide a categorization for each of these types using external resources and statistical algorithms. We extract keywords, and each of these keywords has an associated relevance. And we extract any other kind of data like time expression, money expression, fonts that would be useful for other applications. And finally, at the top you have sentiment. So maybe not that relevant for a piece of news, but for tweets it's definitely relevant to know if the tweet is saying something positive about a subject or negative. It could have a lot of applications, as you imagine. So just briefly, one of the uses of text classification, the thematic categorization that we use, is whether the tweet is on topic or off topic. So if we're following a sport event, probably if the tweet gets classified as something like politics, it's not important for that moment. In our text classification tools, you can define your own categories for your own business needs. We use sentiment analysis, as I said, positive, negative, or neutral are the standard offer, but we're also able to analyze if the tweet is subjective or objective, like for tweets linking to pieces of news. We have made a great effort to try to understand Twitter jargon and training the models to work well with short text, which is pretty difficult, and handle all of the Twitter conventions. We have other advanced features, like we can associate the sentiment with particular entities or with pieces of text in greater pieces of news. And finally, the other one that we have been using is topic extraction. That is the functionality that allows you to extract relevant entities and categorize them. We can provide detailed information for each entity or class that we are able to identify. And for social TV, we can also extend it with additional dictionaries, with programs, with actors, whatever information we can extract from external sources. And finally, during the last year, we have made a great effort to link to external data sources. So once we know that we're talking about a person, we can find a URL in the web of public data that represents that person. To give you an example, this is for Antonio Banderas. We're able to find or to link to the data, to the Wikipedia page of Antonio Banderas, also in Freebase. So this is a functionality similar to the Google Graph that you could use in your application, or we're using in our application. It's just a REST API. It's working for different languages, and it combines the best of every world from linguistics and resources that we extract and create internally to statistical methods and rule-based methods. We use the best tool for each of the functionalities. And very briefly, I presented just the core technology. On top of that, we are building vertical layers that are very suitable for specific applications. And we're focused on social media, understanding social media, and providing applications for semantic publishing, so that, for example, a newspaper could categorize their news and have a better archive, provide recommendation based on the extracted data, etc. So, by the way, you can use it yourself. We have a free plan if you need to analyze unstructured data. So once we have the tweets enriched with all this kind of data, the next step is to store it and be able to query it on real time with low latency. And for that, we use SenseiDB. Okay, this is a semi-structured database, distributed, that works in real time. It has been open sourced from LinkedIn, which and uses several of their components, including Thoi, that it's a real-time search engine built with Lucene components, Bobo, which provides faceted search, and Apache Kafka that has made into the Apache family, but it's also from LinkedIn, and it's a pub-sub system, queue system, very simple. Okay. Some of the features, well, it has full text search. It's able to store structured data and also unstructured data. So it's very useful for this use case. In fact, it powers one similar functionality in LinkedIn, like LinkedIn Signals or the homepage, where they are providing recommendation based on your profile, and also the activity of your friends in social networks and in LinkedIn. So that's one of the things that is interesting of this database. It's also very good at handling faceted search. I will go in detail in the next slide. But one of the good things is that it's built for scalability with a very high rate of real-time events to index, and it also provides low query times while it is updating on real time. One of the limitations is that you only can have a single table or a single collection, and it needs to be flat. So if you have JSON data, as we have from Twitter and our own metadata, we have to flat it out in some in a single table. And about the distributed properties, I will talk also later. So for faceted search, those that have been using Amazon, probably you're familiar with that. It's a very common pattern of use in product stores, where you can make first a query, and then you can navigate for some of the attributes of the product and start filtering. So this is the same that we are using for building some of the online applications I told you. The good thing about facets in SenseiDB is that they are predefined. And as they are predefined, SenseiDB keeps in-memory structures to make all the aggregation that is required for the facets to work. Okay. It has a rich variety of facets that it's able to handle simple types, but also complex types like dates, which is very interesting for doing the time-based visualizations, because it could deal things like time histograms. And these are the basic types that you can store in the data. But on top of that, you have a wide variety of facets, like single facets, multi-label facets. You can define histograms on numeric values, and for dates or timestamps, you can define time ranges. That also provides a very interesting query language for that. You can also store hierarchical facets, like for text classification features. Regarding real-time indexing, the objects that SenseiDB define are, well, events, data events. All the data events form a data stream, and if you want to read a data stream, you have to program your own gateway. It has some that they already provide in SenseiDB, like reading for a file from a JDBC, from a relational database, GMS, or even Kafka. You can even program your own, like for Twitter. One of the things I really like from this database is the query language, because if you have been working with MongoDB, I really hate the JSON query language. Sorry if Luca Olivari is here, but it's not made for humans. This query language is based on SQL, but it's much more simple. We just have one table. So it has operations to search, to filter, like the where, on several fields, to support the facets, an operation called browse by. And it also has operations to provide relevance measures. So by default, the database orders the hits by recency, taking into account the last tweets that you indexed. But you can tweak the relevance in order to include more weights for any other field that you come up. Okay, this is a very simple example of the query language. We're just selecting the tweets are talking about Top Chef, and we're browsing by the hashtags, the user screen name, which is the name of the user that produced the tweet, and the URLs that are shared. I don't know if you're able to see that, but, well, I skipped the document results, but you have the three facets here in this screenshot. And if you see, the query times are very good, even if you're constantly updating. And even if you have bursts of data events that you have to index because the people is commenting a goal. So a little bit more about the query languages. This is how you can query for a concrete phrase in the tweets. You can check what are the people that are mentioned in the same phrases, or in these tweets, on what is the sentiment about. You can apply this where operation to the fields and the facets to check out only the last 2 hours. And as you see, I particularly like the simplicity of the language. Well, like that is the way that we build different facets for the things that we're trying to show in each of the application. Time range facets for the time plot, the list of entities for this faceted search, and trending topics for a program, etc. Regarding the distribution, or the distribution properties of SenseiDB is horizontally scalable. You can have several shards in each of the nodes, and the shards could be replicated in each node. The partition key usually should be the ID, but I guess you could change that. And on top of that, you have a query, the query layer that is in charge of redirecting the queries to each of the nodes and then performing the final results. And the coordination is in charge of Hadoop. Yeah, this is pretty much what I said. So just only to remark that you can add nodes in hot swap nodes. So if you need more processing or more storing capabilities, you can do it without shutting down the system, the cluster, the SenseiDB cluster. So other features that we are not using, but they're very similar to for those of you that were at the Splout SQL talk before lunch. It also have integration with Hadoop, so you can do simple analytics with Hadoop, or we can do any kind of analytic with Hadoop, do pre-aggregation, and put it on the index directly. And so it's pretty similar application. And you can customize the relevant models. And recently the query language also supports more complex queries, not just counting the number of times a facet appears, but you can do other operations with MapReduce. So finally, the lessons we learned. Okay, SenseiDB is pretty good for what we choose it. It's good for searching and indexing on real time, supporting a load of query, and handling the variance in indexing data events. In fact, as Spanish TV phenomenon Spanish social TV is still growing. With a couple of nodes, we're able to handle most of the traffic that we're getting from Twitter. Even for large events like sport that get a million of comments every match, in this order. I particularly like the query languages, if I didn't mention it again. And I think it's a very good solution if you want to support real-time exploration of a data set as you are acquiring it too. So in our case, we're working in an iterative manner. So we're producing new visualization, check with some people, do you like it or not? What should we include in this? It's still a growing area, so it really supports the way that we work. Regarding some of the limitation, well, it's not Solar or Elasticsearch is not well documented. It's still thriving to survive, so maybe not the safest choice for new project. The fact that you have a single table where you have to store all your data, it's a limitation. Because, for example, if we want to build user reputation we have to build a different cluster for that or use another storage system. It could be tricky to implement some of the facets that we like, and some of the we found some limitations on that. We're able to provide much more detailed information than what we are able to retrieve. And well, one of the issues is it's difficult to manage because the linking guys open sources all the engines, but they didn't open source their monitoring system, which is obviously internal. So even if it has GMX, it's not as good as and friendly for administrators as Solar or Elasticsearch. And regarding the Soviet LTV tracker, we found also some things that we would like to do regarding the information that we're able to extract. We're hitting here a problem because Twitter stream is still new, so we're not able to group mentions across different tweets when they have different names. And this is something the research community and NLP are doing. Okay, it's easy to do at the application level, but it's not easy to do in the general level. So this is something that we're also working on. And well, for comparison, for those of you who know Solar or Elasticsearch, both of them have near real-time updates, or you can configure them for that. But in our previous experience, it didn't support that well the ratio of high updates or high indexing data events. Regarding the facets, Solar have even simpler facets and quite rudimentary. I like much more the facets and the query language that you have in Elasticsearch. Well, the query capabilities. The query language is, again, JSON, difficult to write, difficult to get it right, and difficult to write it automatically. But some of the capabilities are more advanced than SenseiDB. And as I mentioned, well, they have better managing toolset to check if your cluster is available, what are the problems in the different nodes, etc. And well, I heard when we have been experimented with some of the, we have started to experiment with some of the stream processing frameworks that appeared during the last couple of years. And I believe they could be useful. They could have their time, especially in the pipeline of processing elements to make it, again, much more configurable. But I'm not sure that they would substitute any of these three for storing the data and querying it. Okay, so that's all. Thank you for your attention. And what questions?
Well, questions, yeah. We have one question right here.
Hi.
Hi.
One question. You've said that 2 nodes should be enough for social media in TV. How many times do you save the data? Because this is incremental. So if you save it more than, I don't know, the time, you will need more space.
Yeah. I mean, we're just trying to save the online data, but we're keeping all of them. So it's enough. So, I mean, the real problem here is not the amount of data that you put in the store, but the rate that you are indexing. Okay, so we can have like 1,000 of tweets indexing all the time and doing the complex analytics. But that, yeah, one node should be enough if this is your average ratio. But the problem with Twitter data is that it's very bursty. If you look at the timeline plot that I showed you, well, it has high peaks, and you have to design for that.
Hi.
Hi.
When analyzing the tweets of the people seeing a TV show, have you found any skewed data maybe the people that tweet is not the same population as the one that see the TV show?
Yeah, definitely. The Twitter data is skewed for younger users. Yeah, that's something that the people that it's interested in the applications already know, but they see Twitter users as prescriptors of something that will probably come up in much larger volume in the following years. So they're not using it for audience metering, but it's interesting data for them. And it's not that interesting the numbers, but the interesting part is what the people are saying. That's why we're using the text analytics part.
Thank you.
Hi. You mentioned you are using the linked data in some of the validation for the discovered objects inside the Twitter description. This is so complex to get all the relations. If you are referring to some concept in ontology, so you are getting additional relations and additional features which may go exponentially in your big data problem. So how are dealing with this referencing to this knowledge repository?
Okay, we're using linked data, but we're not indexing all the relations that we have in linked data. We're just interested in using linked data because we want to group all the mentions for a person across tweets. And for that, we need a unique identifier. And we think linked data, whether you choose Wikipedia or Freebase, could be an option for that. So we want to be able to group that Chicote, Alberto Chicote, Chef Cote, and all of the things that people come up to refer to this guy may be linked to this data. And the difficult part, obviously, is to discover all the alias and make it on a stream. And this is the part that is not solved. But we have all the entities that we have in our data store are, well, not all that we could link to the open data have a pointer there. So we can use this as an identifier, at least for this data. And for the others, as I explained, or as I tried to explain, you can do it at the application level. So you can incorporate new knowledge for your applications with additional actors or whatever you have in your program, if you're focusing on doing a high-quality application for a program.
Okay, any more questions? No. So let's all thank Cesar.